Good evening, everyone. Tonight we're going to talk more about perpendicular bisectors and angle bisectors. First, we know that a perpendicular bisector is a line that cuts a segment in half at a 90-degree angle. So in this picture, CD is a perpendicular bisector of AB because, as we can see, AP and PB are congruent, and also we have a right angle here at point P. And also we are defining equidistant, which means equal distance. It sounds just like the word. Now let's discuss the perpendicular bisector theorem. This states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So what that means is since C is on the perpendicular bisector, then AC is congruent to CB. We also have the converse of the perpendicular bisector theorem that states that if a point is equidistant from the endpoints of a segment, then it must be on the perpendicular bisector. So, if AD is congruent to DB, then that means that D lies somewhere on the perpendicular bisector of AB. Let's try an example. Line BD is the perpendicular bisector of AC. It wants us to find the length of AD. Well, using the perpendicular bisector theorem that we just talked about, we know that if a point lies on the perpendicular bisector of a segment, then that point is equidistant from the endpoints of a segment. So that means that AD has to be equal to CD. So when I plug in my pieces, I have an equation that I can easily solve. First, I'm going to subtract 3x from both sides, and that gives me 2x equals 14. When I divide both sides by 2, then I find that x is equal to 7. So I need to plug in to find AD. So since AD is 5x, then that's going to be 5 times 7. And so I find that AD is equal to 35. Now I want to discuss something called the circumcenter. The circumcenter is the point of concurrency of the three perpendicular bisectors of a triangle. So what that means is if I find the perpendicular bisector of all three sides of my triangle, they will all meet at one point. That one point is called the circumcenter. It also has other properties, like the fact that it's the center of a circumscribed circle, so that means the center of a circle that the triangle would be inside, so that the vertices of the triangle are touching the edge of the circle. And also, the circumcenter is equidistant from the vertices of the triangle. So all of these purple lines are the same length. Next, let's talk about an angle bisector, which is a ray that divides an angle into two congruent adjacent angles. So we've talked about this before. So BD is the angle bisector of ABC, so it cuts the two parts in half, meaning that ABD is congruent to CBD. Also, let's talk about the distance from a point to a line. This is the length of the perpendicular segment from a point to a line. It's very, very important that you emphasize and underline perpendicular because, like we can see below, DC is perpendicular to BC and DA is perpendicular to AB. So the distance from a point to a line is the perpendicular distance between the point and the line. Now let's discuss the angle bisector theorem. This states that if a point is on the angle bisector of an angle, then it is equidistant from the two sides of the angle. So what that means is if AD bisects the angle and DB is perpendicular to AB and DC is perpendicular to AC, then those two distances, DB and DC, are congruent to each other. And the converse of the angle bisector theorem says that if a point is in the interior of an angle and it is equidistant from the two sides of the angle, then it lies on the bisector of the angle. So if DB is perpendicular to AB and DC is perpendicular to AC and DB and DC are congruent, then that means that AD must be the perpendicular bisector of BAC. Now let's try an example. Find the value of x so that P lies on the bisector of A. Well, like we just discussed in the converse of the angle bisector theorem, if P is going to lie on the angle bisector, then that means BP needs to be equal to PC. And so if I'm going to solve for that, I need to plug in, and I get the equation x plus 3 is equal to 2x minus 1. I can subtract x from both sides, so I get 3 is equal to x minus 1. Add 1 to both sides. So we find that 4 is equal to x, or I can switch it around and say as my final answer that x is equal to 4. So if P lies on the perpendicular bisector of angle A, then that would mean x has to be equal to 4. Let's try another example. Find the measure of angle GFJ. Alright, well if we notice in the picture, we have two perpendicular lines to the sides of the angles, both coming from J, and we see that those two segments are equal because they both have a measure of 7. So that must mean that angle GFJ is congruent to JFH because FJ is our perpendicular bisector using the converse of the angle bisector theorem. And so if we know that these two angles are congruent and we're looking for GFJ, then we know it is equal to JFH. So the measure of angle GFJ is equal to 42 degrees. The angle bisectors also form a special point inside of a triangle. It's called the incenter. The incenter is the point of concurrency of the three angle bisectors of the triangle. So what that means is if I draw the angle bisector of each of the three vertices of my triangle, they're all going to meet at one point. That one point is called the incenter. The incenter is the center of the inscribed circle. So what that means is it's a circle that is inside the triangle so that it touches each of the sides at exactly one place. Also, the incenter is equidistant, so it's the same distance from the sides of the triangle to the incenter. So the three dotted purple lines are all the same length. And that's everything for this video. See you in class.